Hello, everybody. My name is Mikhail, and okay. Hello. Okay, great. So my name is Mikhail, and I work in iOS platform team in Mercari. And today I'm going to share some ideas about iOS unit tests and how we can run them faster with Bazel. So in this short talk, I will try to give an overview on how iOS unit tests look like from the build system perspective, like how Bazel executes this unit test, how remote execution affected, and finally, I will share some problems and possible fixes and optimization. But before we start, how many people here actually work with iOS or macOS related stuff? And Bazel maybe? Okay, not many. So anyway, probably if you like work with C++, maybe Go, actually pretty much everything what you can compile with LLVM or other compilers should be useful. But yeah, just take the idea. So let's take a look on small example project, which can help us better understand how we can build iOS unit tests with Bazel. And the first thing what we have is Tokyo build library, which is Swift library. And this is the definition of this library. Pretty simple, straightforward. The library contains some Swift source code. And yeah, this is how we define it in build file. So the next thing what we have is Tokyo build test library. This is a bit more interesting because this is still Swift library, and it contains Swift test code. And here's the definition. You can notice that test-only argument exists here. So this test-only argument is not from iOS Swift rules. It actually comes from the common Bazel attributes, and it forces the target can be used only for the test purpose. Like it can be released to the production. So, but inside the iOS or Apple rules or Swift rules, it actually adds xctest framework to the link options, which allow us to write the test inside this Swift library. And finally, we have Tokyo build test, which is iOS unit test bundle. Yeah, this thing we define in the build. And the overall structure, pretty simple, looks like this. We have test lib, which depends on our production code. And we have test, which depends on our test lib. And transit dependency to the production code. So let's try to build it. And if we execute this simple command, we'll get Bazel run, and Bazel will first combine two static libraries, and then compile this thing together to the xctest framework bundle, xctest bundle. And yeah, this is how xctest bundle look like inside. If we would have dynamic libraries or any assets, they will also be bundled together to this place. And yeah, now we don't have it. We have only static libraries, so we only have one binary which contain all this production and test code. Okay, now we know what is inside xctest bundle and how it's been created. Let's try to test it. To do so, we need to run this simple command, right? Bazel test. And yeah, by the way, I think I can mention that it's not necessary to run Bazel build and then Bazel test. You can run just test and it will be the same result because build kind of included. So also important thing, even so we use Bazel, under the hood, Apple rules, Swift rules, and most of the related to the iOS development rules, they still use the tooling which used by Xcode build system. So it's kind of just wrapper on this. Let's take a look on slightly simplified test execution flow. So we need to focus on these two things today. How we can set up environment and how we can execute test. Actually, Bazel will do this for us. Yeah, so first let's check environment setup step. In this step, simulator for iOS test execution is preparing. It involves the Bazel will check if correct simulator, for example, it can be iPhone or iPad, with correct iOS version is exist in the system and is it ready to be booted. If it's not, then it will be created and then booted. So creating a new simulator for each test theoretically is the best option, right? Because we guarantee that each test execution is independent, and between tests there is no shared state, and like a fail in one test will not affect fail in another. But there are some problems with this. I will show later. In the Apple rules, you don't need to read the whole log. But in the Apple rules, the temporary simulator will create it by default. So these two lines, when Bazel will create simulator, execute the test, and then remove it after all. And the time which we spend for this test creation is quite small, just around 1 second. For Mac Mini machine, it will be 1 to 2 seconds. After simulator created, we need to see what happened when it's run, right? So there are two possible options what can happen next. I mean, there is third one that it's gonna crash, but we'll talk about these two. Depending on the type of the test we try to execute, we will have like at least two options. So the first one is unhosted test, also known as the logic test, and second type is the hosted test. Let's talk about unhosted test. The main difference between them is that unhosted test doesn't require the host application to run the test itself. So as a result, we don't even need to boot a simulator. And however, there are some limitations where we can use it. For example, some UI behavior is not available when you work with unhosted tests. For example, as far as I remember, navigation stack doesn't work properly. So if your unit test, for any reason, contain UI navigation, it's not going to work. But in the same time, other stuff, like a Swift UI, for example, still in place. So you actually can use it for visual regression test, for example. Visual regression test is snapshot test. Like you create a snapshot of the screen and then compare them to the next run. So this can be used. Yeah, unfortunately, Apple doesn't provide a good documentation about all this unhosted and hosted tests. I saw only one mentioned indirectly in one place. But however, there is a good article by my friends, written by my friends, which is describe the whole logic about this unhosted and hosted test, about Xcode agent, how it's executed, and so on. So maybe useful for people who work with iOS. Actually, the article described in terms of Xcode build system, but to be fair, it's completely the same idea. With Bazel and Apple rules, we are a bit luckier because iOS unit test by default is unhosted. So you kind of don't need to care about until it's break. Because as I said, in some cases, you need to have some functionality which is not available in the unhosted test. So you might need to use hosted. Yeah, and as I said, hosted test doesn't have the limitation because what actually happened when you run it, it will run the application on the simulator and application will run the test. So it's kind of complicated chain of stuff. Yeah, again, you don't need to read this through, but I just want to show that in some cases, when you run hosted test, might took up to 20 seconds. I saw up to 1 minute just to create simulator and to boot simulator. So it's actually what can happen that you have 5 seconds for the test execution and more than a minute to initialize the environment for this execution, which is kind of sucks. Yeah, I think the basic idea, what we need to remember, that we should use unhosted test as much as possible and only fall back to the hosted test when some required functionality is not available, sorry, for the unhosted test. Okay, let's move to the next step, test execution. In general, this step is outside of build system level, and it's happened on runtime level in Swift, right? After everything already prepared and ready to run the test. However, there is still one trick which I need to mention. It's test parallelization. So Bazel by default already run a lot of things in parallel, right? With jobs and local test jobs options, we can kind of control, I mean, with a lot of other things as well, but we can kind of control some stuff about test parallelization. But Bazel parallelization happens on the bundle level. So if you have two bundles, we can run and test them in parallel. But this doesn't allow us to run tests inside these bundles in parallel. So to enforce it, as I mentioned, because Apple rules in Bazel and Swift rules in Bazel, they use environment provided by Apple. We can do this by simply use these arguments from the Xcode build system. So Bazel kind of send it through we provide it to the Bazel, and Bazel will send it to Xcode build system. Yeah. So one note to remember, we can use Swift test parallelization inside test bundle with Bazel. So we can run in parallel while we're running in parallel. This is kind of fast. Okay. In every topic what we covered before, we did not touch on remote execution. However, everything what we have discussed is valid not only for single execution machine, but for multiple machine as well. So using multiple execution machine brings us a lot additional performance boost, but it also adds some overhead, which can be quite big in some cases. The source of the performance boost is quite clear. We have more CPUs, and we can run more tests in parallel on different levels. But what about overhead? Where it comes from? So as we discussed earlier, xctest bundle by design must be ready for distribution. So it must contain all required symbols from static libraries, from dynamic libraries, from assets and everything to bundle together to be able to distribute across different machines. So if dependency graph is small, the final bundle size also will be small, which makes sense. Less symbols, less libraries, less assets, small final size. But if dependency graph become much bigger, the final size of the xctest bundle also can grow dramatically, potentially up to a few hundreds megabytes just for one test bundle. And usually, even in small projects, we don't have just one test bundle, but we have more. For big projects, it may be more than 10, 50, or even 500 test bundles. So that means that we have hundreds of xctest bundles with a lot of duplicated symbols, because all this, whenever you have it, static libraries, dynamic libraries, or assets, going to be duplicated in each of this xctest bundle. So, and the size of the whole this setup might be quite big and potentially can reach up to a few hundreds gigabytes of the artifacts after simply run Bazel test command. We actually had it. Yeah, we might consider to change dependency graph, but unfortunately for the large projects, it tends to have much more complicated dependency graph, which cannot be flat, right? Does make sense to make it flat. So we have many artifacts, and we need to produce and bundle the final xctest bundle with static libraries, dynamic libraries, and so on. So the more xctest bundles we have, the more actions like this we need to execute. And we haven't even started to run the test yet. This is the whole step as preparation for the tests. The overhead of moving all these things and artifacts around on the preparation step actually might jump up to 80% of the total time of the Bazel test execution. So it's not a Bazel problem, to be fair. It's Bazel tried to run this as efficient as possible. But the problem is having a lot of heavy test bundles with small numbers of tests inside. So what actually happened, you have a few hundred megabytes of the binary, which have 20 or 30 tests, which is insane. So to reduce the overhead while still maintain the performance boost from the remote execution, we need to simply reduce the number of the test bundles. So we need to balance the number of the test bundles and the number of the tests inside each bundle. From our side, we also cannot simply use we cannot use one xctest bundle because we will lose all these multi-machine parallelization options. And this is an example of the changes with this strategy. So the x-axis here actually in hours. So in some cases, reducing the number of small test bundles can dramatically reduce the whole test time. Yeah, I should mention that this is the sum of action which run in parallel. So In the real world, it still was just 15 minutes, but it wasn't really efficient in terms of remote build execution and in terms of machine utilization. We can kind of run it in 50 minutes on one machine without any problem now. Yeah, in short, we need to keep the balance between count of unit tests inside one bundle and amount of tests per bundle. Yeah, and in summary, first, choose efficient setting for testing by selecting between hosted and unhosted test. It's actually quite important. Then use parallelization inside test bundle when it's possible. And we need to balance between number of xctest bundles and number of the tests inside each bundle. And that's all from my side.